Welcome to Vocabulary Video 5.1. This video is on the mole part 1. The mole. A mole is a quantity, or 6.022 times 10 to the 23 particles of something. A quantity is like a dozen, for example. It is also known as Avogadro's number. It can be represented in a chemical equation by the coefficient in front of a compound or an element. Examples. 1 mole of water consists of approximately 6 times 10 to the 23rd molecules of water. 1 mole of pennies is approximately 6 times 10 to the 23rd pennies. Such a large number is used in comparison to atoms because atoms are so incredibly tiny that we need to take a whole lot of them to be able to take the mass of them. Molar mass. Molar mass is the mass of 1 mole of a given substance, either a chemical element or a chemical compound. The units are expressed in grams per mole. Example, the molar mass for water, H2O, is approximately 18.0 grams per mole. The molar mass can be calculated using the mass numbers on the periodic table. This is a mathematical example of what we're going to be doing in class, but how I got this 18.0 grams per mole is by taking the number of atoms, so this corresponds to this, and this one corresponds to the imaginary one right here. And then these numbers right here, these are the mass numbers for oxygen and hydrogen on the periodic table. And then we get a total of 18.0152 grams per mole, which then I rounded to 18.0. We're going to talk about this more in class, but just know that molar masses are very important, and we're going to be using them in all the different types of problems for this unit. Percent composition. The percent composition of a particular element in a compound is the percent of the total mass that is due to that particular element. Below, in my example, I have a compound that's composed of carbon, oxygen, and hydrogen, and each element out of the compound composes a certain percentage of the overall compound. If you look at my picture, this entire pie chart is 100%, while oxygen only comprises about 51.41%, carbon comprises about 42.12%, and hydrogen comprises about 6.48%. When we add them all together, we get our 100% of our compound. Molecular formula. The molecular formula is the actual formula for a compound found in nature. These can sometimes be extremely large. For example, we have the molecular formula of caffeine is C8H10N4O2, and it looks like this big compound right here. So even though in math class we would reduce this down possibly, the molecular formula is the entire compound with no reduction whatsoever. So we would leave all of those elements and atoms in there. This is in contrast to the empirical formula. The empirical formula is a formula that gives the simplest whole number ratio of atoms in a compound. This is the simplified version of the compound. For example, the compound C2H4 right here can be reduced by dividing each of these by 2 to its empirical formula of CH2. This is just like simplification in math class. In this chart right here, we have all the molecular formulas, which again, these are the full, entire, large formula. And then we have the simplified empirical formulas over here. You'll notice that in the second example for H2O, that they are the same in both columns. That is actually okay. So if you cannot reduce a compound anymore, then the molecular formula and the empirical formula are the same.